In this video, let's start with the basic question: what exactly is this machine learning and why is it very important for us? See, here when we talk about machine learning, so machine learning is a part of applied mathematics and the computer science. In case of machine learning, we make use of tools from mathematical discipline like the statistics, probability, and the optimization theory in order to extract the patterns that are present in the given data set. The core idea from machine learning is we are going to learn from the data set or learn from the examples. So we prepare a data set with the examples and the machine learning system learns from this given data set. In other words, what we do is we are going to give the system, that is the input, as well as the desired output. We'll provide both input and the desired output for my given system, and the system is going to figure out how to perform the conversion between input to output. So this is the main idea between on this machine learning. So we are going to send the desired input to a system. Okay, this system is going to receive the desired input and the output, and this system is going to decide what and how to perform the conversion between this input and output. To give you an example, I can collect a data set with a description about the bike and their prices, and then we are going to provide a machine learning model with this data set, and we are going to teach it by showing us price of the bike as well as the bike itself, and this process is called as the training or sometimes known as fitting. So I'll have my system, and for the system I'll be sending my input and the desired output. In this scenario, the description about my bikes as well as the prices of the bike. I'll provide both the information to my system. I'm going to call this system as a ML system, that is my machine learning system, and I'll give both of this data to this ML system, and my ML system is going to perform the activity what we call it as fit, that is it will learn the pattern between the bike and the prices, and once it learns the pattern, what we will end up is having a system or a trained model. We call it as a trained model. This will be the overall output. So this is what a machine learning is. In the scenario of machine learning, we will collect the data set, and here in the data set we will have both input and the output, that is desired output. Now with both of those combination, we are going to generate a trained model. So whenever we are training, we'll make use of both input and the output. Now once the training is complete, we can use this trained model, and then we can just give out the description of the new bike. I can send the description of the new bike, and then I can use this trained model to generate the prices of the bike. So this is called as the prediction. Okay, so all we need for machine learning is a data set in which for each input, it could be the bike, we have the desired output, that is the price. As you can clearly see, this process is very different from the traditional software engineering approach. So without machine learning, if you think about it, the analyst and the developers, they actually have to look into the data set and they have to manually try to find the patterns. But after that, they actually come up with some logic, which is like the set of rules for converting the input to the desired output. And then they are going to explicitly encode these rules using a programming language like the Java or Python programming language. And the overall result that we would see is called as a software. So in case of traditional software engineering, okay, in case of traditional software engineering, you can see that I'll be providing both data and code. Okay, now using this combination of data and code, so I'll be writing the rules in the traditional software with the help of programming language, and I'll be generating the output. in summary, the difference between the traditional software engineering, that is the traditional software system approach, and the system which is based on machine learning is, here in case of machine learning, we give the system, that is the input and the output data, and the result is a model. Okay, now this result is a model which can transform the input into the required output. The difficult work is actually being done by the machine. We need only supervise that training process so that we can make sure that the model is actually good. In contrast, in the scenario of this software engineering, that is traditional software engineering, we actually find the patterns in the data ourselves, and then we write the code which converts this data into the required outcome using the manually discovered patterns. So this is the main difference between the traditional programming approach and the machine learning. Now that you have understood what exactly is this machine learning, now let's go ahead and understand the types of machine learning. See, when we talk about the types of machine learning, practical machine learning. So here, when we talk about this machine learning and compare it with the rule-based system, let's take up a scenario. So to illustrate the difference, okay, so the use case that I'm going to consider is a spam detection. Okay, I'm sure everyone is aware of the spam detection. See, a spam detection is a system which we are trying to build, which will help us to say that whether a particular email that I have got, whether it is a spam email or not. Okay, so let's assume that I'm going to build a system which is capable of detecting the spams. Now, we have the system that has been built, and the users have started complaining that they are receiving some unsolicited email with the advertisement. Now, in order to solve this, so the expectation is we want to create a system which is going to mark whatever the emails that I'm going to receive, they have to be marked as whether it is a spam email or whether it is a non-spam email. So this is the kind of system that I have to build. Okay, now the users started complaining that they are receiving some unsolicited email. Now, the obvious way to solve this problem is look at the emails that we are actually receiving. For example, we can actually check the sender. We can also look into the content of those emails. Now, if you find that there is actually a pattern in these spam email, then what we can do is we can list down the discovered patterns and actually come up with the simple rules to catch these messages. For example, I can come up with a simple rule that says as if sender is equal to prices@online.com. I'm just giving you a random example. If the sender is prices@random.com, like at online.com, then I'm going to classify it as spam. And here, if the title, okay, if the title says lottery, okay, then I'm going to call it as a spam. Maybe I'll write one more logic, okay, one more condition that says as if the title says winner, then spam. So here I have come up with 3 rules based on the examples that I have got. So the 3 rules are: if the sender is prices@online.com, then it is spam. If the title says lottery, then it is spam. If the title says winner, then it is spam. Then if this system does not come across any of these conditions, then I'm going to say it's a non-spam email, which is a good email. So this is a rules that I have found from the examples of the spam email. Now, once I have found these rules, the next thing that I'm going to do is I'll start writing the program. Okay, I'll just start writing a computer program, and maybe I'll be using the computer program to go ahead and implement this logic. For example, I might make use of the Python programming language, and I'm going to create a spam detection service. Now, once I create this spam detection service, I'm going to ensure that whatever the new email that I'm going to receive, so this email will be now sent to my spam detection service. So once I send this new email to the spam detection service, my spam detection service is going to tell me whether the new email is a spam email or a non-spam email. Okay, so here what we have done in this scenario is we have found the rules from ourselves by looking into the examples that we have got, and then once we have found the rules, we have written the logic in a coding environment, in this example by using the Python programming. Then I have built it as a service. Now whatever the new email that I receive, I'm going to send the new email to that spam or non-spam service, which will help me to classify whether the new email belonging to a spam email or a non-spam email. Now, what we have found is after this, I would say implementation, it was able to succeed at first, but we started seeing few more complaints from the users. So we started observing that, okay, there are some few more scenarios where users are still receiving the spam email. Now what we have done is, okay, the user started receiving more and more emails, and now once we started observing this new pattern, okay, we have found there are some additional new patterns as well. So what I have found is, okay, so now this time they are not using the email sender as prices@online.com. Now what they have done is they have actually changed to a new website which says that promotions@online.com. Then they started coming up with a new word. They have mentioned as, so they started using a few more different words that says as 100% discount, and I would say great chance. So these are the new words that they started using in their email. Now apart from that, they started using the other domains as well. Now there are other domains that they are now using. They're using the other domains like promotions.com. That's another website. They started using it. And even in the body of the email, they are talking about deposit. So if these are the conditions that are met, okay, you will say that additional to the old condition, if these new conditions are met, then you are going to say that it belongs to a spam email, otherwise it's a non-spam email. So what we have done is, even for the next iteration, we have analyzed the existing data, and once we have analyzed the existing data, we have updated our rules, and once we have updated our rules over here, next we are going to send a new email, whatever that we receive, to the updated email classification service. Now this email classification service can help us to classify the given email as a spam email or a non-spam email. But there is a problem with this approach. See, when we are building these kind of rule-based system, as and when the trick used by these spam email senders, as and when these trick gets changed, at that time it is very difficult to maintain and understand. And in some scenarios, it becomes very impossible, I would say, to include the new patterns in the code without breaking the existing logic. So in the long run, it is very difficult to maintain and adjust the existing rules such that the spam detection service which we have created would work efficiently. And by working efficiently, that means I would expect that the email to be classified to a spam or a non-spam. So it is very difficult to maintain such kind of rule-based system, and this is the kind of situation where the machine learning can actually help us. In case of machine learning, we typically don't attempt to extract or to get the exact pattern manually. So what we do is we are going to give this task to the statistical method. Now by giving the system a data set with emails marked as spam or non-spam, then we will also describe each object, that is the each email, with the set of its characteristics, which we call it as features. Now based on this information, the system is going to try to find the patterns between the data and the target label without any human help. So in the end, it is going to learn how to combine the features such a way that the spam messages are marked as spam and the good messages are non-spam. So with the case of machine learning, the problem of maintaining the handwritten rules or hand created rules would go away. Now whenever a new pattern comes, that means if the spam email senders comes up with a new trick, then I don't have to worry. I can just send in this new data to my system. My system is going to learn the pattern, and it will learn the pattern and it will update its rules automatically, because learning is being done by the machine itself using the statistical methods. So it would learn the pattern, and finally it will also help us to classify the new data as well. Okay, so this is the overall idea and the difference between the traditional programming approach and a machine learning approach. Now, once you have understood this traditional programming and machine learning approach, the difference between them, here, when we talk about the applications of machine learning, the applications of machine learning are endless. It can be applied to any domain wherever the data is present. Like for example, suggesting the price of the bike or predicting whether the customer is going to stop renewing my service or not. And suppose if I want to classify the documents to one of the class, or find the groups in a given data set. So these are all the use cases where the machine learning can be really helpful. Now that you have understood about the machine learning, now I'll stop the video over here. In the next video, we'll talk about the types of machine learning, and then we will go ahead and get started with a typical process that is involved in the case of machine learning. So I'll see you in the next video.